In this video, we'll look at manipulating dynamic particles using XP Flow Field in spline mode. So let's get started. So before we even begin creating our first scene, let's get our project organized from the get-go. So here is our untitled scene in Cinema 4D. So we'll go to File, Save Project As, and I've created a library called WaterSpin, and this is just so we have got ease of access, so whenever I open up a search Explorer window, we can find our folder quickly. But obviously you save yours in your documents or on an external drive, wherever it is you want to create your project folder. So within my library WaterSpin, we have our parent WaterSpin folder. So let's make a new folder per Cinema 4D scene. So here's our news folder. We'll call this first one 01 Spheres Base. And this is going to be the start animation of our scene. So then we can double click to go inside our Spheres Base folder. And this is where we're going to name our first one. So let's call this the same, 01 Spheres Base, and then we'll give it a suffix, version 01, and then we can incrementally save as we go along. In fact, I like to just separate out those versions with an underscore. There we go. So that's good. So let's hit save. Fantastic. So now we're ready to go, and at one point obviously we're going to be caching this, and we'll be caching every scene. So let's get organized with where we're going to save our cache data before we start as well. So we'll go down to our File Explorer, bring it up. So here is my WaterSpin library. Let's go into Spheres Base and let's make a new folder, and I'll just call this cache. And that's where we're going to be putting our cache information. So that's going to work perfectly for us. Fantastic. Okay, so we can now close this down and we can start building this scene. So first of all, we need to bring in a collider object, which is going to kind of confine our particles and make them form that spherical shape. So we'll do that with a sphere object. Let's go to the parametric objects and we can bring in a sphere. Let's hit ND so we can see the lines. And what we'll do is we'll change it from this standard type, which gives us these kind of pinched poles, to a icosahedron type, which is a much more even triangulated mesh. And we will just increase those segments to 32 to make it a bit more smooth. There we go. Great. Now we want to kind of lock this sphere in place. We don't want to accidentally move it. So we'll do that with a protection tag. Let's go to the tags menu. Now I'm in R21 here, and in R21 Maxon reorganized all of their tags into new sub-menus, which actually they all make an awful lot of sense now. It was a really good job. But it means that if you're using a version of Cinema 4D prior to R21, your menus might not look the same. So I'm going to go down to my rigging tags, and look here, I have a protection tag. So I'm just going to bring that in. Now, if your menus look different to this, because they're in a previous version of Cinema, then you can still, all of the tags are still there, they're just in different menus. So if you're struggling to find a tag that I have accessed, you can use the commander to find it instead as a bit of a shortcut. So to do that, you hold Shift and press C, which brings up the commander, and then you can just type in, look, let's just type in protection, and there we have, look, protection tag, and we can just double click this and it will go to your object. So that's a different way of searching for these tags if your menus look different. Okay, very nice. So let's also put a display tag on here so we can just change this into a permanent kind of wireframe view. So we'll go to tags, and in the render tags, we have a display tag. So we'll just stick that on. And then we'll activate this top window, and the shading mode, we're not going to use shading, we're going to use lines, which gives us just that kind of mesh of those polygons. And if we want to see even less detail, we can change the style from wireframe to isopalm, which is just going to give us the very base wireframe mesh. So that's looking really good. Okay, good. So now let's talk about our X particles. So we are building the base spheres. Our red shiny spheres is going to be the start of this, and everything else is then going to build on top of that. So let's go to our X particles menu, and we're going to bring in an X particles system. And this is this nice kind of folder hierarchy to keep all of our different X particles objects organized. And when you bring in a new system, it automatically creates a default X particles emitter for you, which is this square emitter. And if I hit play, it's spitting out particles on the +Z. So with this system, let's just do a couple of things before we start. I'm going to highlight the system. Let's disable the icon in viewport, which is this X particles icon here. If we just uncheck that, it'll disappear. Just make the viewport a bit more tidy. And we're also going to check only modifiers in same system. Now this will make sense a little bit later on when we start combining multiple X particle systems in the same files. But basically what this means is, if you have an emitter spitting out particles, that emitter will only be affected by modifiers which are sitting in the same system. If you've got 3 systems in your scene, for example, and in one of the systems is the turbulence, it won't affect emitters from other systems. So again, I'll explain that in more detail when we start layering up and having multiple systems in our scenes. But for now, just so we don't forget, we will make sure that that is clicked on. Okay, so if we play this, obviously this isn't right yet. What we want is we want these particles to interact with our sphere. We want them to be trapped inside this sphere. So to do that, we need to make the sphere a collider object. So let's highlight the sphere. Let's go to the tags menu, X particles tags, and we have a collider tag. Click that on. Now you're going to see some weird behavior. Look what's happened. The particles go, when they hit the sphere, they start kind of moving direction and going outwards. So what is going wrong here? Well, this is the way in which the collider tag is set up. By default, it is set up to interact with the normals, the outside of the normals, but we want them to bounce on the inside of the sphere. So if we change this from outside to in, now it's starting to bounce inside that sphere, and they're trapped inside it. Good, we'll take away the bounce. We don't want bounce because we want these particles to kind of swirl around and then slide around the shell of this sphere. So we don't want bounce because we don't want them to bounce away. And we can maybe put a bit of friction in, but we can make adjustments to this later. So now you can kind of see that it's working. They're hitting it and then they're sliding around the shell of this sphere. Okay, that's good. Let's put a few more frames on the timeline. Let's put it up to, say, 200. Okay, and now we've got these particles sliding around the outside of that sphere. Fantastic. All right. So what we need now is we're going to need this emitter to be much smaller. We want it to be pretty tiny, actually. So we could just eyeball it with these handles and bring it way down, something like that. And now it's going to be a really thin kind of stream of particles. All right. Very good. So now what we need to do, we've got our basic setup sorted now. We've got our collider object, we've got our emitter. Now we need to start using the X particles tools that we can use to manipulate these, to start them flowing around in that kind of flowy helix motion. So that's what we're going to move on to now. So what we're going to use is a spline to control the flow of the particles. So what we are going to do is this. We're going to draw a spline, which will be the basic path that we want this kind of helix motion to take. So what I'm going to do is go to my top view. So if we hit F5, it gets the shortcut to show all of the different orthographic views. Here is my top view. So if I then hit this button here, it makes that view full screen. So now we're looking down upon our sphere. And in fact, I'm just going to hit F1, which takes us back to our perspective view. Let's just put a camera in here. Now, this isn't going to be the final camera for production, but it's just kind of a bit of a reference one, really, to make sure that we're looking at it and we're drawing our splines from the correct angles. So I'm just going to stick in a camera, and there. Let's get this protection tag. I'm going to hit Control and hold it, and drag it up to make a copy of it and put another protection tag on the camera. So now we can't move the camera. Okay, so now if I hit F5 to go back to our orthographic views, then we'll go make the top one fill the screen. So now we can see, right, so this is our camera looking at our sphere. So we've got a bit of a frame of reference about where our spline needs to be. So let's get our spline tool. We'll have it in Bezier mode. Let's just dolly in a bit. So what we're going to want to do is we want it to be something along these lines. We want it to go, first of all, go towards the camera, then away from the camera, and then towards the camera, and then round. Something like that. So let's just start that motion. So we'll go point it in this direction. Then we're going to start aiming back. And then we're going to start going back again. We can maybe move that one up a bit. All right, and now we're starting to come right past near the camera. So this one could perhaps, we could bring it out like this, something along those lines. Let's just bring that down a bit. And then we want it to carry on swirling all the way round. So I'm just going to hit 2 and just dolly out a bit. All right, so something like that. And of course we can make adjustments to all of these lines at any point. So that's looking pretty good. And then one last point there. Okay, then we hit escape, and now we have our drawn spline. Very good. So if I hit F1 now, it's going to go back to the perspective view, and we can see we have our kind of helix shape. Now it's very flat at the moment. We don't want that. We want it to have a bit more of an interesting movement. So the way we'll do that, really simple, just highlight the spline. We'll go into object mode, and I'm just going to make the spline white so you can see it more easily. So let's just go to the basic tab, display color on, and now you can see a white spline. Okay. So then we're going to just hit our rotate tool. And you can see now what we want to do is just put a bit of an angle on this. So let's have a look. Where are we? It's going to come upwards towards the camera. So a bit of a tilt that way. And then something like that. And then what we could do is we could tilt it another way. So I'm going to go to our world coordinate system. At the moment we're in object. If we hit to world, you'll see that the rotational widget resets. And now we can tilt it. Which way should we tilt it? We could tilt this a little bit down. So it's going to go down and then up and then down and then round. Let's have a look. Okay. So if you imagine, what we're trying to do here is work out flow of particles. And what's happens is that the particles are going to come out the emitter. They're going to go down and then whoosh upwards and back, and then down and round, and then slide up the outside of the sphere. So obviously this spline is completely editable. And this entire force field that we're going to create from this spline is going to remain editable throughout. So we can make whatever adjustments we like. But that's looking pretty decent for now. Right, so this is going to make much more sense when we bring in our next object. We are going to use a dynamic object. Let's just go to our Dynamics Object menu. We can go to the Dynamics Objects list, and we're going to use a fantastic object called the XP Flow Field, which basically helps us make customizable, editable force fields. So we'll bring this in. Now, by default, this force field is set to the flow to be in the default direction, which is on the plus Z axis. You can see all these arrows pointing in the plus Z. And the field is set to direction, which means that it won't give particles any extra speed. It'll just change the direction in which they're going. And it's going to make them all go in this direction. But if we change this from the default flow, which is the plus Z, to along spline, click on that. Now we can drag in a spline. So let's get our spline, put it into the objects. And now can you see that our arrows have changed? And now they're pointing in the direction of this spline that we just drew. So they're going to force the particles to move in this direction. So we can reduce the cell size, which means we have more arrows, which will make it much more, it'll make it stick to the spline much more easily. Okay, so now we have created this force field, forcing any particles to move in the direction of these lines. Fantastic. So let's just go to the display and just uncheck vectors. So now we're not looking at those arrows and we can see exactly what's going on. So now if I hit play, let's see what happens. Right, so we're getting a little bit of movement from these particles, but then they're sticking onto the sphere. So they're not really following the direction of our spline much yet. But that's because if we go back to the flow field object, to the general tab, the strength is only set to 10%. So it's not really giving it much of that directional force. So let's put this way up to 100 and let's see what happens. Ah, look, now it's really respecting that initial blast of our spline. It's respecting this until it gets to the edge of the sphere and then it's just moving round. So that's looking really good. It's not quite right yet, but we're getting there. So let's get our emitter. Let's go to the move tool and let's just position it so it's a little bit closer to the beginning of the spline. Very nice. So that's kind of the basics there. That's our movement. And that's looking really good. So we've used our flow field to create this custom force field, which is forcing our particles to move along the direction of that kind of helix spline that we've done. And of course, this spline remains completely editable. So if I just take one of these points and move it, it will change the flow field. Look, it's changing it as we move it, so it remains completely editable and procedural throughout, which is really, really exciting. So I'll just move that back to where it was. Excellent. So now we have got that. Now we can move on to the next stage, which is actually starting to make this look a little bit better. And we're going to do that with some modify and some really nice, clever data mapping. So let's talk about the particles first. At the moment, we're viewing these particles just as dots, and so we can't really see their size. We're not seeing the true radius of these. So let's change that. We'll go to the emitter. Let's go to the display tab, and we have got the editor display set to dots. So let's change this to circles filled. Just so we get good smooth playback, I'm going to reduce the filled circle segments down to 7, which just means these are going to be less detailed. They're going to look more like platonics. So we can't really see the individual particles because they're all on top of each other. So Cinema 4D's got a really nice display mode with some ambient occlusion using the OpenGL options. So let's do that. We'll go to Options. Let's select SSAO. And now you can see, look, you see that subtle ambient occlusion shadowing, which means we can see these individual particles. But we need these to scale up over time. We need them to be born with absolutely no size and gradually scale up. And we're going to do that with a modifier, and then we're going to randomize the size of those particles. So we've got some big and some small using some neat data mapping. So what we will do first of all is let's go to the emitter and let's go to the emission tab, and we'll put the radius down to 0. Okay, and actually, whilst we're here, we don't need to be emitting this amount of particles per second, and we don't need to be emitting every frame. So let's just emit for, say, 120 frames, and then let's have the birth rate at about, I don't know, let's say 650. So we've got slightly fewer particles. So we have our particles emitting. We can't see them because we've put the radius down to 0, but they are there. So we're going to use a modifier to scale these particles up. So let's go to our modifiers menu. We'll go to the control modifiers, and we're going to control the scale. So let's bring in the XP scale modifier. Now, by default, the XP scale modifier is going to change the particle radius, and the mode is it'll change the value over time. So what it's saying is the radius change is going to change 0.2 centimeters per second. So let's have a look, and you can see they're growing up, and they're going to carry on growing and growing and growing until they get the maximum upper radius limit of 20 centimeters, and then they'll stop growing. And you can see that's happening, isn't it? But this isn't what we want, because it's far too uniform. So actually, we're going to do something different. We are going to scale them up using data mapping instead. Now, don't be intimidated by data mapping. Don't be put off and think that you need to be some kind of, coding whiz to be able to do it. It is really simple, but it is massively powerful, and it just once you get your head around it, it just unlocks so much potential in XParticles. So the way we're going to do it is this. We will change the operation from change value over time to, we're going to, what do we want to do? Set value. We want to set the radius, and the value is going to be 20 centimeters. So now, without data mapping, every particle is just 20 centimeters all the time. That's not what we want. What we will do is go to the Mapping tab, and now we're going to add a map, which is going to get us to control this. So let's add a map. And there's two things we need to do. We need to pick which parameter out of all of these we want to map. So what we want to do is, let's go to the parameter, and we want to map the radius value. So let's click that. And actually, we are going to map it to the particle age. And then all this is, if we just press play, you'll see something happen. Look, they're all growing up, and they're finally resting at 20 centimeters. And what's happening is this. We've got this graph, and this x-axis here represents whatever range min and range max you have. So here is frame 0, here, and here represents frame 90, and that's because we've got it set to particle age. And then the y-axis represents the percentage of whatever value you've got here, 20 centimeters. So at the bottom of the y-axis, it has no percent of the radius, which is 0. And if this dot is at the top of the y-axis, it has 100% of that value, which is 20. So what you can see here is, on this knot, it's on frame 0, every particle has 0% of the radius value, which is nothing. And as the particles get older and come up towards frame 90, they get bigger and bigger and bigger until they reach 20 centimeters of radius value. And we can see that happen. They start from nothing and they scale up. So if we put this knot all the way to the top, this is just saying that no matter what the particle age, they'll always have 100% of that radius value, which is 20. We could put it the reverse, look. So now it's saying they'll be born with full radius value of 20, and as they get older, they'll get smaller and smaller. Let's have a look. And then they get smaller and smaller until they hit frame 90. You can change this. Look, it could be over only 20 frames. So they'll start with a full radius value, and now they'll shrink down, and by the time they get to frame 20, they're 20 frames old, they're nothing. They've shrunk to nothing. So that's really cool and really simple. We don't want it that way. We want it this way, like this, something like that. So they're gradually scaling up over time. All right? So that's the first stage. But remember, we said we want these to be random. We want some to be big and some to be small. We don't want them all to scale up to 20 centimeters. Well, this is the beauty of mapping. We can layer up our maps. So this is what we're going to do with this one. We're going to bring some random scaling in now using mapping. So what we need to do is this. There's one step that we need to do. Let's go into our emitter, and I'm going to go to my extended data tab. And in the physical data, we have got all of these different options to add different types of physical data, and each has a variation slider. So look, we could add smoke, fuel, fire, temperature, and they all have a variation slider. So what we're going to do, ignore what these are called for this trick. We aren't using a modifier that takes advantage of a smoke value or a fuel or a fire value. So all we're going to do is we'll use fire. All we're going to do is use these fire values as just a number holder. And what it'll do, if I put 50 fire in here, every particle will be given a fire value of 50. Okay, and to check that, I'll show you how we can check that that's working. Let's go to X particles, other objects, console. The console is really cool, and a lot of people don't know about it. So what we can do, look, I've got my emitter highlighted. In the console, I'm going to click Get Active Emitter. And then I'm going to go forward one frame. And now it's showing you all of the data that emitter is holding. So look, at the moment it's showing the particle ID, the age, and I've got the fire value selected as well. But look, if we go to data to display, we can display all of the possible data that any particle can display. So let's put radius. It has a 0 radius because the modifier hasn't kicked in yet. Let's see what else that we could look at. Let's look at speed. They all have a speed of 150 because that's what the emitter's spitting out. And if we go forward a few more frames, we'll get more and more particles. And look, we can read every single particle in our scene. We can see exactly what its values are. So that's really cool. And look, every particle has been given a fire value of 50. But if we put a variation of 50 in, that means that every particle will have a fire value of anywhere between 0 and 100, because it's 50 with 50 before and 50 after. So let's just go forward a few frames. And now you can see, look at the fire value. If every particle has got its own random number between 0 and 100, and it's being kept in this fire channel, which is brilliant. We're not using it as fire, we're just using it as a channel, as a placeholder. Okay, now this is going to make load of sense as soon as we get this into our scale modifier. But all you need to know at this point is every individual particle has its own fire value, and it's a value between 0 and 100. Cool. So let's get back to our scale modifier. So now we're going to add a new map. So I'm just going to disable the first map that we made, which is scaling them up over time, over the particle age. Let's add a new map. And we're going to do the same thing. We want to map the radius value, which we've set to 20, but we're not going to map it to age this time. We're going to map it to the fire value. And the fire value, our particles have a fire value of anything between 0 and 100. So on the default, that's fine. So what this is saying is particles with a fire value of 0 will have 0% of the radius value. And particles with a fire value of 100 will have 100% of that radius value. And then it'll tail off anywhere in between. So now if we hit play, you'll see that we've got particles of different sizes, which is fantastic. Now, we want far fewer bigger particles than little particles. So what we can do to sort that out is, look, we can just change the curve. So only the particles with a really high number, a high fire value, get to be large in radius. Something like this, look. So we could make it maybe something like that for now. So now there's going to be far more smaller particles than there are larger particles. So now we've got this randomized amount. So that's looking pretty cool. So now if we then now enable the initial map that we made, these will work in conjunction with each other. And now we will get the fade up over age, and then they'll settle at these randomized sizes. Fantastic. So that's working really well. So now we have got them scaling up correctly. it still doesn't look very good because all of these particles are all overlapping, aren't they? And they're not looking dynamic. They're not really interacting with each other. They're just all on top of each other. So the next stage is to get our nicely scaled particles to start acting dynamically. So how do we do that? Well, we need another dynamics object. So let's go back to our dynamics folder. This is where we got our flow field in. Go back to dynamics. So what we're going to do is we're going to use constraints to make these particles interact with each other. And the constraints will do two things. Let's bring it in and I'll explain. So let's go to our dynamic objects and we're going to bring in a constraints object. Now, the first thing we need to do is stop these particles from intersecting, because that's not working. So if we go to the collisions part of our constraints and activate collisions, you'll see that the particles are no longer interacting with each other, overlapping each other. They're being kept separate, and already it feels like we have a much more dynamic simulation going on. So that's working really nice. Maybe we could just reduce the stiffness of that collision a little. Let's have a look. All right, so now they're kind of moving around and that's looking really, really nice. So what else could we do? Well, let's just have a look. They're kind of moving around and being shunted around quite a lot. So we could actually arrest some of that by using a little bit of this friction setting. So if we bring, if 100% friction, it'll be too much. Friction is great for removing some of the energy from a simulation that's a little bit too frenetic. So that's a little bit too much. Let's reduce this down a little. Maybe just a little bit of friction like that. There we go. And that's looking pretty nice. And we've got these particles moving around each other, bouncing around. And there looks like there are kind of big gaps at the moment. And that's just because we've got our emitter display mode set to, let's go to my display mode. We've got it set to circles filled, but we're hardly using any circle segments just to make sure that it plays nice and quickly in our viewport. If we increase these, you'll see that the particles are kind of much more kind of tightly packed, and they're looking really nice. And we're getting this nice movement as they collide with each other and move around. That's looking really good. Okay. Excellent. So we're pretty much there with our first scene. We have got our particles, we have got them moving out, we've got them scaling up, we have random amounts, they're coming towards the camera, interacting with the sphere, moving around, and this is our base animation. So this is working pretty well. So we'll just keep, do you know what we could do? Perhaps we could arrest some of this movement a little bit more. Our flow field is doing its thing, and it's creating this force field, forcing them around. But of course, remember, the flow field just continues and it's pushing them all the time and all the time. And it will be an idea to stop that. And then at this point, to have a little bit more of just kind of residual speed movement rather than constantly being forced around in this direction. So we could do that by taking our flow field object to the object tab, and we can just keyframe this strength down a little. So let's get to a frame where we've already got lots of nice motion, maybe about frame 70 approximately. Let's hit a keyframe on our strength of our flow field. Let's move forward to when all of our particles are out. So somewhere maybe around here. Let's just keyframe that all the way down and see if we get a little bit nicer, smoother motion. So here we go. And so there's less directional force with these particles. Yeah, and that's looking nice. And it just kind of slows it down a little bit. And now it's the particles which are interacting with each other which are actually causing the movement rather than being forced around in that direction by the flow field. And so it's this kind of mass particles bouncing off each other and forcing each other around at this point, which then gives us this nice fluid, organic kind of rotating movement. So that's working really nice. I'm I'm pleased with that. That looks great. So just to be safe, let's increase. We're going to cache this now, but to be safe, let's just increase this to say 250. In fact, let's make it 300 frames, and then we've got 10 seconds because we're at 30 frames per second in this scene. We won't need this many, but look, let's just be safer rather than sorry. So we've got our animation moving, scaling up nicely, rotating. And then our flow field stops, and now it's just the constraints making the particles bounce off each other, which is giving this really nice, flowy rotational move. That looks great. All right, so let's clean up this scene a little. We have our XParticles system, and then we've got these objects that we're using within the system, but they're not inside it. So let's just tidy that up. So we'll move our sphere into the other objects. Okay. Let's move the spline into the other objects as well. And then let's just rename our emitter, just to be sure. So we'll call this emitter base spheres. Okay, there we go. Excellent. So now we're going to get this cached. So let's go to other objects, and we'll go to the object tab. And in the other objects, we want to bring in an XParticles cache object. Okay. So what we're going to do is we're going to cache these to external files, which will cache each frame. It'll have a file per frame to a location that we choose. So let's go to our Explorer, and we're going to go to Libraries, Water Spin, Spheres Base, and we already made a cache for it. So let's hit cache and hit OK. All right, and we'll cache all of the data. So now all we need to do is build the cache. This is going to run through pretty quickly. I guess it's going to be about, what should we say, maybe 20 seconds. So caching all the way through. So at the moment, this is writing a file, every frame into a sequence, which will go into this folder location. And then once it's finished, instead of XParticles having to simulate and work out all the calculations for how those particles are moving, it can then just read that information from those sequence files. So here you can see now that we have a emitter-based sphere with a red cache tag, which means it's got cached data. And now we can scrub backwards and forwards, and it's reading this information from disk. And actually, when we scrub this quickly, you can really see that nice bit of kind of residual movement that the constraints gives us once we've keyframed down that flow field. And if we hit play, now we're getting this real-time playback, and that's our initial movement. And that's looking really nice. So obviously it looks nothing like the finished animation, but this is the base that we need to move on to the next step. And the next step is an exciting one, because we're going to use this base to create the next part of this, which is the really cool fluid splash animation. And that's the scene that we'll move on to next.